Hello everyone, welcome to Business 2400. In this video, we will talk about goal programming, and I will try to convey the concept through examples step by step. So let's start with a simple example for more clarification. Imagine there is a company with two branches or production units, production lines, providing three types of products for the customers. You can see the related information in the table. For example, unit number one has a daily operational cost of 200,000 and unit two has 190 daily operation costs. Production unit number one has the production capacity of 12 tons per day for product number one, and also with the unit two has the capacity of 10 for this product. The company has contracted a customer to supply them with 40 of product number one, 40 tons of product number one, and 20 tons of product number two, and 80 tons of product number three. Now the question is that based on the different operating characteristics of these two production units, how many days will take to fulfill the contract while minimizing the related costs? Like always, first we need to define the decision variables. Let x1 and x2 be the number of days per week that production unit 1 and unit number 2 are operating respectively. And the objective function is looking for minimizing the cost, which is simply the summation over multiplication of the daily cost and the number of operating days for each unit. Then I can generate the constraints based on satisfying the demand. I need to produce at least equal to the customer's demand, so they are of greater than or equal type. And the last two constraints, as you can see, x1 less than or equal to 6, x2 less than or equal to 6, are due to the limitation on the working days per week. I can only work to maximum to the 6 days per week. Now, the optimal solution, this is the whole model, and the optimal solution for this problem can be obtained as x1 equal to 2.5 and x2 as 6 and z plus as 1640. So unit 2 will work with the maximum capacity to satisfy the demand, and unit 1 will be working 2.5 days of the week. And the related cost is 1640. So what we will do now, we will focus on the constraints, and let's replace the related values of x1 and x2 in the constraints. And we will see some interesting things here. For the first constraint, if we replace the related values, we have the final value of 90. What does this mean? It means that we have produced 50 more products of number 1 than I needed to satisfy the demand. How about constraint number 2? Again, I have satisfied the demand, but I have produced more 7 products. And regarding the last constraint, well, I have done a good job, and there is no extra products here. Therefore, as you can see, we have to deal with lots of excess amount, which is a challenge for the company if they do not make the right decisions. The good news is that there are methods to prevent this from happening. Let's say we have more than a single objective function. So I have a new mission here. I have to minimize the operational costs, and also I need to avoid producing extra amount of products as much as possible. And goal programming is one of the methods to deal with this type of situation. And before we move forward, let's review some points. In a linear programming problem, the different goals of an organization might be summarized in the form of a single objective. Let's say such as maximizing the profit or minimizing the total cost. But in real world, this is not always the case. In reality, each organization is trying to achieve several goals at the same time, such as, well, increasing or at least maintaining the market share, diversity of the products, stabilizing the prices, and many other goals. Goal programming handles several goals simultaneously in the problem. And the foundation of the work is that for each of the goals, a specific value is determined as the ideal value, and the related objective function of the goal is formulated. And then we will look for a solution that minimizes the total deviation of each goal from the ideal setting for the same goal. Now, let's focus on different types of constraints that we will face. But before doing so, let's first focus on different types of deviations that I can have. Well, we need some variables to show the deviations. Two types of deviation exist as underachievement variables and overachievement ones. In the underachievement variables shown by the negative superscript, we have not reached to the goal. Let's make an example. For example, if we have the if we have the set of goals as 1,000 and we have obtained 800, the situation is that I have a shortage or underachievement of 200. On the other hand, if I achieve 1,200 instead of the preferred goal of the 1,000, then I have an overachievement equal to 200, which is shown by a positive superscript. So let's go back to the constraints I mentioned you. If we are looking for obtaining a value around the RHS or right-hand side or the BI, I'm looking for something around 800, around 1,000. This is the situation we have both types of the deviations. And if it is a greater than or equal type, we only need to use the underachievement deviation. And if the constraint is of the less than or equal type, we will use the minus overachievement, as you can see. So we are dealing with 4 states here. In the state number 1, both of the deviational variables are equal to 0. And here we have a complete achievement of the defined goal. There are no deviations. If only the underachievement equals to 0, then surpassing the defined goal has happened. If only the overachievement is available, it is a failure to achieve the defined goals. And if both of them are they have some value except 0, and because they are greater than or equal to 0, they are more than 0, there is no if here. This situation cannot happen. It is not a possibility. We can't have both surpassing the goal and not achieving it at the same time. So let's go back to our problem. The initial cost in the single objective status was 1640. If we add the second objective, which is avoiding the extra production, the increase in the initial cost is inevitable. However, the company will consider a limit for this. Let's say they 1800. Therefore, a solution with a cost around 1800, sorry, is acceptable. So I'm going to have both of the deviation forms for this goal. The second changes will be according to the amount of each product. The goal is to avoid producing more than necessary as much as possible. Here we will represent the deviation from cost with C plus and C minus, C plus with a positive superscript and C with a negative superscript. This is only to differentiate this goal from each product, because I want D1 represent for the product number 1, D2 to represent for product number 2, and D3 for representing product number 3. Simply, you can consider D1 instead of that C for this goal. So the new objective says that whatever we decide in terms of production in both of the units, the related cost must remain around the goal of 1800, which is adjusted by the deviation variables of C plus and C minus. And the rest of the constraints will be built according to the previous slides explanations. Let's go back there, and you can see the constraints with the greater than or equal type. They have only plus di minus in their left side. What we will seek is to minimize the deviations in the objective function. And you see that the objective function of this problem is minimizing the deviations from the goals. To solve this model, there are different approaches. We will focus on two of the methods, which are the weighted goal programming and the preemptive goal programming. In the weighted goal programming, we consider weights to each variables that is linked with the underachievement and overachievement deviations. Then we will solve the resulted objective, including the weighted deviation element. And in the preemptive method, we will decide the priority levels for the goals, meaning that priority level 1 for the most important goal, and so forth.